Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
We're given a car with an initial velocity of 20 meters per second, and the driver of the car sees a red light up ahead. It takes the person 0.530 seconds to hit the brakes, which is called the reaction time. So we are asked to find how far the car travels while it's stopping if the acceleration once the person's foot hits the brakes is -7 meters per second squared. So we need to break this problem up into two parts. The total displacement is going to be the total displacement is going to be the displacement traveled while the person is reacting plus the displacement while the person is braking. So let's solve for each of those two parts one at a time. The reaction displacement or reaction distance, we're just moving in one direction, so we don't have to worry about direction, is just going to be the velocity that the car is traveling times the time interval that we're discussing, which would be the 0.530 seconds. So 20 meters per second times 0.530 seconds, put it in parentheses, would give us a distance of 10.6 meters. Okay, so that's how far the car moves even before the driver hits the brakes. Okay, well, once the driver hits the brakes, we know that the velocity at the end of the problem would be 0 meters per second because the car is coming to a rest. So the initial velocity, again, is 20 because that's how fast the car is moving before the brakes are hit. The acceleration is -7. So we're not given the time that it takes for this car to stop. We could find it, but we can also use the equation v final squared is equal to the initial velocity, or v naught squared, plus 2 times acceleration times the displacement. So 0 equals 20 squared plus 2 times -7 meters per second squared times the displacement. So moving my 20 squared to the left-hand side, I have -400 meters squared per second squared is equal to -14 meters per second squared times x. I need to divide both sides by -14. And we have our answer for the braking distance part of this problem, which would be 28.57. And x is over here, so 28.57 meters. Of the two, this is the braking distance. So the two distances that we need to add together are the 10.6 meters and the 28.7. So my total over here, 10.6 meters plus 28.57 meters, and that's going to equal 39.2.17 meters. Which rounded to three significant figures gives us 39.2. Our total displacement.